Finally, we got a bit out from all of these, grammar, parsing, parsers, everything. We're going to move to a different start. We're going to have at least maybe 4 or 5 chapters covering what we're going to talk about now, which is more focused on imperative programming languages, okay? Then after that, we're going to have maybe a couple of chapters covering the object-oriented paradigm. If we have time, we're going to take a look quickly about the logic paradigm and the functional paradigm. But now, the main focus here is about the imperative languages. We're going to start looking more, not on the, the parsing and the grammars. We're going to look more about the difference between naming, the difference between data types, binding. We're going to understand all of these things. So maybe this will be a bit more interesting for some of you. So what are we going to talk about? So the idea behind variables. So what is the variable? So let me just quickly do something. Okay. Okay, that's better. Okay. What is the idea behind variable? We said, what is imperative programming language? It's based on what? From the first lecture, we said it's based on the abstract of von Neumann architecture. Who remembers a bit what does this architecture consist of? Memory and processor. So the idea of the imperative programming language is that we're going to have a memory, like we're going to store variables in the memory, and then the processor, for example, the idea, like if you say int x, you reserve something in the memory, and then you say int x equal 20, you manipulate this value and so on. Now the variables, specifically the variables, represent which part of this, the memory or the processor? Of course, the memory, because it's the variable, so it's the memory. Very quickly, some examples. What do you mean by that? So you'll have, for example, simple types like integers are often directly mapped to memory cells, correct? Integer can be very direct. So you said like int x, it's mapped directly. But some other cases, complex abstraction, multi-dimensional arrays, all of these things require software mapping functions. So these just are examples. Now, very quickly, just to go and see a bit of difference between the functional programming and the imperative is that it is true also the functional programming allows named expression, of course. But what's the difference? If you were talking here about a pure functional programming, and named expressions are immutable. So they are like constant. Okay, so for the functional programming, if it's a pure functional programming language, so it's a pure functional language, do not have immutable variables like imperative. But for example, like Python, that can act like what functional and other things, it can have both, right? But we're talking about the pure functional languages. We're going maybe to go through some of these if we do a specific lecture about functional programming. Now let's start with the main thing about variables, the names. How can you think about design issues when it comes to a name for a variable? Philippe.
Has the same name as
For example, having same exact name of 2 variables have the same exact name. What else? Isan.
Make a variable that's used somewhere else in the system as like a
Global.
keyword.
Exactly. So for example, let's say one of the keyword is int, right? Like in C, it's int, right? And you're also naming a variable int. This is also, what do we have? We also have reserved keyword, like, the index out of bound error. This is a reserved keyword. So this kind of, what else? Something that you always do, always, all the time. Students do this error. That's not an error like this.
Scope of the variable, like is it just inside the for loop or?
This is also very good, yeah. But one that usually I always see it in the programming assignments is that when you don't name them correctly. You're going to say, okay, you know what? Everything is called X1, X2, X3, X4, X5. So if I'm reading this, I was like, well, what are you referring to, right? What does X mean? Is it grades? Is it whatever? So usually one of the issues is these things. Now, another thing, name case sensitivity, for example. Some languages are case sensitive. Some other languages are not case sensitive. This can be an issue. Special words, all of these kinds. So let's start with the length. What do you mean by length? Is like the example that I gave you. If it's too short, they cannot be connotative. What do you mean by that? If I say X equal 80, if you're reading this without looking at the whole code, can you understand what I'm trying to say? Why? Because it's too short. But if I tell you, for example, student score equal 80, it's self-explainable. Which one is better, having student score equal 80 or having X equal 80 and then comment next to it, this is the student score? You see, guys? So this is now we're trying to understand more about the fundamentals, the concept of programming language, that any computer scientist needs to know these things, so you will become a better computer scientist, of course. So if it's too short, they cannot be connotative. This means, as we said, if the name is too short, whatever. Some examples are what? C# and Java has no limit of the length. C++ has no limit, but a bit different things. C99, I think, is something old. It used to have a limit. All of these things. Another design issue is special characters. Some programming languages have special characters, like what? Go PHP. It will have a $ in front of the variable, right? So these are special characters that you have to insert to be able to define. Perl, Ruby, use the @ for example. Another one, which is something that you will face a lot, is the case sensitivity. Is Java case sensitive? The naming in Java. Is Python case sensitive? You see, we don't notice it. If you're always working with the 1 or 2 languages, you're not going to notice because you memorize. But if you work with many, you're going to notice. Technically, the majority are case sensitive. What do you mean by case sensitive? So first of all, the main disadvantage of case sensitive is readability. I'll tell you why. So let's take this example and see. Int total equal 10 and total equal 20. They are two different names. They are case sensitive. Java is the same thing. Python is the same thing. So, okay, it's something good, but also readability-wise, the programmer may make mistakes using this total or this total. So the readability is an issue with this thing, okay? Now, another example, and other than which one, I think Pascal. Pascal is not case sensitive, for example. Okay, so when it comes to case sensitivity, it's better from a readability perspective. Now, there's something worse than case sensitivity. Is usually, for example, like in C++, Java, and C#, we have the predefined names are mixed case. So you'll have something like this, index out of bound exception. So it has to be written exactly the same to work. So this is annoying, usually. That's why usually what we do as programmer, if one is always working, we just copy and paste it. We don't actually even try to think. Now, of course, if you're using a more advanced, the Eclipse or all of these things, they will do it for you. So make your life easier. Yes?
A lot of programming languages will have equivalents, right? You can write false as an F or a capital F as a C. Or you can write it as a 0.
Yes, so this is 0 is different thing, but like, for example, false and F, this also applies under case sensitivity. So some of them will support this, some of them will not support. So what we're trying to say here, again, because this is how they designed the language. Some of them, they say, okay, it is okay to have the disadvantage of readability, but I'm going to gain more, for example, variable names or whatever. So they chose this over this. because you'll always have advantage and disadvantage. Now, something that I want you to always remember, that the variables will have a 6-tuple of attributes. You may think it's complicated, but no, actually it's it explains itself. So each variable will be connected to a name, address, value, type, lifetime, and scope. We're going to cover them step by step just to understand them. So what is the name? Not all variables have them. Have you ever seen a value without a name? Yes?
Yeah, the scheme, you could do.
Exactly. So this is very, very famous in functional languages. Functional languages will have lots of things without names, for example. But also, if you're using Python, I don't, yes.
Mention the underscore thing. Underscore, like.
Underscore. Also, what else? Yes.
So let's say I just want to pass a value to a function without specifying a variable. Like let's say print hello world. That's print hello world is a variable with that.
For example, and also you're going to use it. That's why I'm focusing on it. Is lambda expression. Lambda expression is supported by Python because Python supports what? Functional language, right? So you can just call it like this. You don't have to actually define to give a name for this function. Usually we just call the lambda function right away. So this is one way to say that some of them will have name. Yes, Benjamin.
If we just remove the result and just put the dot into the print, we put print and then the bracket on the outside, is that technically a variable without a name?
Yes, is whenever you're using this without defining if it's using here or here, it's technically it's without a name. So because this is a function, that's why. So we're saying here, this function doesn't have a name. Yes.
So be the name. Result.
That's what I'm saying. Instead
No,
of
the result is the output of this function. But the name of this function, the output.
The name of the right hands. The result just shares the same.
Yeah. The idea here is this is the result that stores does it store the function? It stores the output, doesn't store the function. So can you now call results with different 10 or 20? You can't. You can try it. So I'm leaving these examples for you if you want to try them. Yes, Philippe.
Can you put a lambda function in the variable? Like the function.
Yeah, I think you can name it in Python. I think I've tried it. I don't remember, but we use lambda functions a lot in machine learning. I remember, I think maybe I've tried it. So we don't want to waste too much questions on.
Why would anyone want to just find?
Sorry? Because if I give you an actual machine learning code, you're not going to understand. So I'll give you something so simple for you to understand. This is a teaching class. It's not like if. Yes, Margaret. Exactly. So the whole it's called anonymous variables, lambdas, all of this. Usually we don't name them, all of these things. But we're saying, why did I give this example in Python? Because Python, usually you're going to use it. Not everyone's going to use scheme and functional programming languages, but Python, this is still used. I use the lambda expression a lot in the machine learning. So now, another thing, the other attribute of variable is the address. Address is very clear. What do you mean by address? Is, let's say you're storing this variable. Where are you storing it? In the memory. So what do you need to access this memory? You need the address. As simple as that. We know that from data structure. So in this case, if I have this function that have int x equal 10 and then print whatever, and then I'm calling this function twice, what would I have? Same address or different addresses? Different? Same? What? Think a bit. So do you see these are a bit more interesting than grammars, right? What would you have, guys?
Different.
Different? Okay, Michael. Different? He said same. Who else? Benjamin, same. Margaret, did you decide? Different? Okay. Felipe.
It can be the same, but normally different.
You're just covering your bases. Yes?
For a function like local variable gets created, but as far as you create the functions, the variable is.
Very good. So here, your friend Is it Ibrahim? No, Ibrahim, yes. So your friend here, Ibrahim, already solved it for you guys. Why this is different? Because this variable x is a local variable. What do we mean? That it only exists inside the function, correct? Can you call this x from outside? So now if outside here I say print x here, I don't have this function. It's going to have error. So this is created locally. That means after this bracket, after I go outside this bracket, this is destroyed in the memory. I cannot keep all the local variables in the memory, right? It's waste of time. That means the first time I called this function, I had the address, let's say 20. But then the next time I entered it, it's a different address because I already destroyed this address. So it's going to be different. This is the thing about local variables. It's very important. These are basic stuff. You need to know it. In an interview, if you make a mistake like this, like whatever you say after that, you're done. Because this is what fundamental stuff. Okay, and then of course, this is the official things from the book. I left it for you if you want to take a look. Now, what else will make different with the address? We gave an example calling the function twice. But what if we have something like this? This is considered a local variable, but this is considered global variable. And if you remember from ITI 1120, when I taught you Python, the first course, I told you, please don't use global variables. It's going to confuse you if you're not used to it. If you don't know how to use it properly, what's going to happen for you? You're going to change the values without noticing because the global variable is going to stay all the time with you until the whole program is executed. That means if I have int x equal 10 and int x equal 100. In this example, maybe the compiler will fail because it's the same name. No. Why, Mateen? No.
Local, you can name it.
Exactly, because we just said local. This when you enter this, you're going to do it and destroy it before even leaving. So it's okay to have same names for the global and things. Now it's not good, it's not recommended because as we said, the length, the name is very important for the thing. But anyway, this X will have a different address than this X. So these will print two different addresses. Okay, so these are very important for you to know. Who knows what does aliases mean? Yes?
When two variable like reference to semantics.
Exactly. If we have something like two variables will refer to the same thing. Now, how can we usually use this in C++ or C? Usually we use pointers. We can do a pointer. We'll say, okay, this int x equal 10, and then I'll create a pointer that will point to x. If I change this pointer 20, it will also change the x. Okay, guys. Now in C, why do we use this? Because usually in Java, we have the immutability. We've covered it, like you can actually change it. And C, usually you have to change it through a pointer. That's why C is considered more difficult to manage than, for example, Java. Now, what is the disadvantage of aliases? Again, readability issue. You're going to have, it's hard to track. And then also unexpected changes. Let's say you changed something in the pointer or whatever. Okay. Now, another attribute, it's type. We're not going to talk about it a lot. We're going to have a separate lecture just for data typing. But do you know what type is? Like integer, float, string. And then the value. What I want you to focus that the attribute value stores two things for each variable. What are the two values that can be stored for a variable? The actual value, let's say I'm saying int x equal 15. So 15, and then also the address of this. So we represent them by L value that represent the address and R value that represent the actual value. And then we have the abstract memory cell. This is not the address, this is the actual cell that we're going to destroy. Lifetime, what is lifetime of a variable? Yes.
How long is in scope?
Scope is different than lifetime.
How long is the life?
This is not an art class. No, but actually, yes. But how much is life? Where? If it's a function,
Is the function is while the
Exact. So if it's a function, if it's a local variable, the lifetime for it is be inside this function. If it's a global, what is the lifespan? The whole program. So that's the idea of lifetime. So of course, I left for you two examples here. Look at it, global and now the scope. What's the difference between the scope is that if I'm inside the function, if I have a local variable, what is the scope of this? Just inside this function. Can I call it from outside the function? No. So that's the scope. But the global variable, what is the scope of this global variable? Is the whole program can access it. So the scope is the whole program, not the function. Again, I gave you an example here. Variable attributes, so explicitly declared and implicitly declared. That's also something good. Now, an example for explicitly declared can be what? And C, the type. So you need to declare the type explicitly. It's not going to work if you don't do that. You need to say int x equals something. So this x is an integer. This y stores float. So that's called explicit attribute. So the type is an explicit attribute in C. What about in Python? Is it explicit or implicit in Python? Implicit. Why? Because I actually can write x equal 10. That's why we're teaching you Python in your first year at the university, because it's much less headache for you guys. You're just starting to learn programming. So we give you the easiest, most flexible language, which is Python. Then after that, slowly you go to Java, C++, hopefully C. So again, implicitly declared can be like Python, can be x equal 10, y equal 40. Who can give me what about static and dynamic? If I want to say static attribute, what attribute can be considered static for C? So is this type, it's explicit, but is it static? What do you mean by static? That it doesn't change. Is the type of C language and Java languages are considered static? So I have int x equal 10. Can I say after that, and then I can say, for example, x equal, no, let's say in Java, we say int x equal 10. And then I'll say, for example, x equal something like string. Does it work? No, it's static. If I defined x as an integer, it's going to stay as an integer. That's static. What is a dynamic? The value will be dynamic. So if I say int x equal 10, then I can say x equal 20. So the value attribute can be dynamic, but the type can't be dynamic. Some other languages will also have the type as dynamic. You can actually change the, like PHP, you can easily change the type. For example, you'll have $ var equal Boolean, like false or true, and then you can change it to a string. It will work. PHP. Yes.
We say int x equals 10, and then strx equals, and then we put hello world.
Maybe you can, but I'm talking about the fundamentals of things, not what loopholes you can do to make it work. Just like the idea of, is it static or dynamic originally? Now you can do lots of things unoriginal way, like as you said. Usually we try to do many things. Even in Python, there is a way to write strings in two different ways. So these things are fine, but we're talking from a concepts perspective. What are the main things? Yes.
So is this different from the final variable in Java when you say like something is final, it cannot be changed?
I'm not sure. Yeah, I'm not sure about this specific thing. The values, I'll have to double check about the final. I'm not sure what it is.
If you declare it final in Java, then you can never change it after that.
Yeah, then it will be transformed to static at this case. But I don't have enough information to give you now. I don't want to just give you something that I'm not sure about. But if that's the case that you're explaining, then yes, it will be static at this case. But again, by default, it's dynamic. Okay. So that's why if you're looking at something, at some of the definitions, you will see some of the languages are, for example, static and dynamic. What do they mean by that? That it can be static, it can be dynamic at other point, but then you will find by default they are, for example, static. By default, they are what? Yes.
So just to make sure, static, we're specifically talking about like typing. It can't be.
No.
Or in general, it can
We
be.
gave an example. Here we're explaining what do you mean by static attributes. Static attributes are determined at compile time and do not change. Attributes. You can find like the values, for example, let's say in functional language, the values maybe are static. You cannot change them, for example. I'm just giving them. These are concepts. And the one that I gave you for type and value are examples that works with these concepts. Okay, guys? I think we're going to stop here. Is it, yeah, I don't know, usually the other class enters at this time. Huh? Okay, no problem. So we will, I'll see you at the lab and we'll continue later.